Hello everyone, so today we are going to go over section 3.4, the chain rule, and we'll be doing this over 2 days. So we're going to start with a little warm-up. You can see here we're given f of x is equal to 4x squared minus 1 all squared. So if we were to find its derivative, what we'll do is most likely multiply it all out. So we have 4x squared minus 1 times 4x squared minus 1. You can multiply this out. You'll get 16x to the fourth power minus 8x squared plus 1. And of course, you will then take the derivative. So f prime of x will be 64x cubed minus 16x. And the derivative of the plus 1 will just be 0. So this is what you were left with. So if the power here is 2 or even 3, then it's pretty easy to just expand and multiply and then take the derivative of the resulting expression. But if you have a higher power, then that's a lot less feasible, because we have to consider all the distributions and things being multiplied out. So what we're going to do instead is use something called the chain rule. It allows you to take the derivative of composite function, something like f of g of x. All right, so in order to use the chain rule, you have to be able to determine what is the inner function of a composite function and what's the outer function. So in this case, g will be the inner function and f is the outer function. Let's look at some quick examples here. So we're given y equals to 2x plus 1 cubed, even the way that that is stated, it makes it pretty easier to recognize which one is the inner function. The inner function is just going to be 2x plus 1. The outer function is the fact that the function is cubed afterwards, so this would be f of x equals to just x cubed. Likewise, for the next example, the inner function will be what's underneath the radical sign, so that would be x cubed minus 2x, and then the outer function would be the square root of x. Okay, with trigonometric functions, also pretty straightforward. So in this case, the inner function is the argument inside of the trigonometric function, so that would be 3x squared. And the f of x would be the trigonometric function itself, in this case, cosine x. And finally, the last one is a little bit more complicated, but if you were to rewrite the function y, you will get y is equal to x squared minus 1 to the negative 3 power. So the inner function would just be g of x is equal to x squared minus 1. And in this case, f of x would just be x to the negative 3 power. Okay, so now that we looked at how to identify inner and outer functions, we can proceed to introduce the chain rule. So the chain rule says that if you have a function y equals f of g of x, then its derivative is going to be y prime is equal to f prime g of x multiplied by g prime of x. Okay, so in Leibniz notation, if y is equal to some function in terms of the variable u, where u is g of x, then dy dx, and that is the derivative of y in terms of x, would be dy du multiplied by du dx. So it's the same thing, but we introduce a new variable u that is just g of x. Okay. So what if you have a composite function with more than two parts. Like you have an inner function and then another inner function and then an outer function after that. Well, then you can simply take the derivative like you usually would with the chain rule. So this would be f prime and then g of h of x, of course. And then you have to take the derivative of g of x. So that would be g prime h of x. And then you basically apply the chain rule again, so you have h prime of x. Okay, so that might be coming to handy later. All right, so example 2, we're going to apply the chain rule to some different functions. Some of them would have been on the first page. So let's see, in this case, we have y equals to the square root of x squared plus 1. So let's see here, y equals to then x squared plus 1 to the 1/2 power. We're going to take the derivative of that 1/2 power, so that would be 1/2 and then x squared plus 1 negative 1/2. And then the derivative of x squared plus 1 is 2x. All right, so then what we're going to do is to rewrite things out slightly. So that would be y prime is equal to 2x all over 2, and then the square root of x squared plus 1. All right, so you can see that the 2's are going to be eliminated, and so you're just going to be left with y prime is equal to x over the square root of x squared plus 1. Okay, so if we were to take a quick look at this Leibniz notation here, we can also do that. Just gonna erase this. Okay, so let's go back. Same example, then in this case, we're looking at the new variable that represents g of x. So f as a function of u would just be the square root of u. Then u is equal to g of x, which of course is x squared plus 1. So we can substitute in, well, actually we can just rewrite this as u to the 1/2. Oh, sorry, that's not what I meant to do. If I take the derivative then in terms of u, that would be 1 over 2 square root of u. And then the derivative of g would be 2x. So dy dx in the notation is equal to dy du and then du dx. And we know what dy du is. That's just 1 over the square root, sorry, 1 over 2 square root of u. And then du dx is 2x. And then if we back substitute everything back, we'll get the same thing. We'll just get x over and then the square root of x squared plus 1. Okay, so the next part is just to look at the chain rule if we already have very well defined inner and outer function from page 1. Let's go through them pretty quickly here. Okay, so the derivative of the first function, that will be 3 and then 2x plus 1 squared, and then we take the derivative of 2x plus 1, which is going to be just 2. Then we can multiply multiply the coefficients together, we get 6, and then 2x plus 1 squared. We don't have to expand that square there. We can just leave it as is, and that will be sufficient. Next one, we are looking at y prime is equal to 1 over 2, and then the square root of x cubed minus 2x. Okay, there we go. And then the derivative of the inner function will give us 3x squared minus 2. So that's really easy to combine together. And we'll just have 3x squared minus 2 all over 2, and then the square root of x cubed minus 2x. All right, and then we have, in the next example, cosine of 3x squared. So the derivative, we'll take the derivative of cosine, which is negative sine. Still 3x squared, of course. And then the derivative of 3x squared is 6x. In this case, there's not much simplifying to do. You can just write it as negative 6x sine 3x squared. All right, and last one on this page. Let's see here. We can rewrite this, of course, as x squared minus 1 to the negative 3 power. Makes taking the derivative a little bit easier. So we have negative 3, and then x squared minus 1, negative 4 power. And then we take the derivative of the inner function, which will give us 2x. And then afterwards, we can multiply everything out and put things in the numerator and denominator respectively. So negative 3 times 2x is negative 6x. And the negative exponent, we can put it in the denominator, so that would be all over x squared minus 1 to the 4th power. Okay, so from there, just want to show you a couple more examples that is a little bit more tricky. Okay, this first one is not too bad. It looks like you might have to apply the quotient rule and then chain rule, but you don't really have to, because you can do the following. You can rewrite this as y equals to 2, and then x minus x squared to the negative 1/2 power. So that way you don't have to use the quotient rule, you can just use the chain rule once. So the derivative then will be 2 times negative 1/2, and then x minus x squared to the negative 3/2, because you subtract 1. And then the derivative of the inner function will be 1 minus 2x. And afterwards, you just multiply everything out and put it all back together. This would be y prime equals to 1 minus 2x all over... Oh, I forgot a negative sign. Sorry about that. There's a negative sign from here. So that would be negative, and then in parentheses, 1 minus 2x. Or you can write it as 2x minus 1 too. That's of course, that will work. And then this part here will be in the denominator, and you can write it as the square root of x minus x squared cubed, and then square rooted the whole entire thing, like so. Okay, so likewise, yeah, so actually, you know what? I'm just going to write that out. Y prime is equal to 2x minus 1 all over, and then the square root of x minus x squared cubed. Okay, so that's a bit better. Okay, so the next question we have just sine square x. So of course that's the same thing as saying we have sine x and then all squared. We can apply the chain rule. We have 2 sine x then to the first power, and then the derivative of the inner function, which is sine x, will be cosine x. So that would just be y equals 2 sine x cosine x. And that's all you need to do. You don't need to apply the trig identity to it. You can just leave the answer as is. Okay, so the next couple, these are the tougher ones because you can see they involve both the chain rule and also the quotient rule in letter C, and then the product rule in letter D. But that's okay. You can only apply your rules one at a time. So y prime is equal to 9, and then inner function is x minus 2 over 2x plus 1. And of course, this will be now to the 8th power. And then you have to use the quotient rule for the inner function. So that would be, let's see, 2x plus 1 times 1 minus x minus 2 times 2 all over 2x plus 1 squared. All right, so if you simplify the numerator in the second part here, this actually will just give you 5. So that's convenient. And then when you write the derivative, you can do something like this. 9 and then x minus 2 to the 8th power over 2x plus 1 to the 8th power. And then the second term, you know that this is just a 5, so this would be 5 over 2x plus 1 squared. So the reason for writing it like this is to show that these two, you can actually combine them together. So this really is y prime is equal to also 9 times 5 is 45. So this would be 45 x minus 2 to the 8th power all over 2x plus 1 to the 10th power. Okay, oops. Last one involves the product rule. It's also a very good exercise on like how much simplifying is sufficient. So let's just look at the question together. We'll take the derivative of the first part. That will give us a 2, of course. And then we'll leave x cubed minus x plus 1 to the 4th power as is. And then plus, we'll leave 2x plus 1 as it's this time, and then take the derivative of x cubed minus x plus 1 to the 4th power. That means we have to use the chain rule, so 4 x cubed minus x plus 1 to the 3rd power. And then we take the derivative of the inner function, which is going to be 3x squared minus 1. So yes, you can factor it and multiply things together, but it doesn't make it much simpler. If you just left the answers as is, that would be sufficient. And that's it. So that's how you can also apply the chain rule alongside another rule that we learned already. So that's it for today. Next class, we'll continue with the second part of the chain rule. Thank you for listening.